Okay, good afternoon, and we are going to continue going to learn about electromagnetism. Electromagnetism, and we are in the midst of a 3.3 that is called electromagnetic induction. Electromagnetic induction. Okay, electromagnetic induction means production of electric current by the changing of magnetic field. Okay, or another word, cutting of magnetic flux. Magnetic field lines we call magnetic flux. So cutting of magnetic flux will produce current. So the magnet, north and south pole, and north and south pole, there's a magnetic field lines between north and south. Okay, and this one is okay, and this is north and south pole. This is north and south pole. This is north pole and this is south pole. Okay, this is north pole and south pole. Okay, this is north pole and south pole. This is north pole, this is south pole. There's a magnetic field lines between we call north and south. Okay, so the magnetic flux, you're cutting a magnetic flux, you cut the magnetic flux. So you must provide the force. You must provide the force. Cutting of magnetic flux produce current. Okay, there's no battery current. There's no battery. Okay, production of induced current by the changing of magnetic field or cutting of magnetic flux. And we learned this one. Thumb shows the Fleming's right hand rule. Fleming's right hand rule is a generator rule. Okay, production of current. So thumb shows direction of force, pointing finger shows direction of magnetic field, and middle finger shows direction of current. So you have to give two inputs. You have to give force. You have to give the force. You have to give the magnetic field. So as output we get current. So the force, the magnetic field is input. You must give the input. Input the magnetic field. There must be magnetic field. Magnetic field is the input. Second input is a force. You take a conductor, you cut the magnetic flux. Or magnetic field lines between north and south. So you cut. So the force is supplied. And the magnetic field is supplied as an input. So force input, the magnetic field input, as output is a current. That is flow the current. Okay, and we learn extensively. We learn the current produced. The current is this is called induced current. It's not battery current. Battery current flow in one direction, positive, negative. Induced current flow in two directions. You cut in this direction, cuts out this direction, cuts in this direction, cuts out this direction, cuts in this direction, cuts out this direction. Current flow this way. Current flow in two ways, two directions. Current flows two directions. So that is what we call it induced current. Current flows in two directions. And we learn also the north pole and south pole. There's a magnetic field lines. You push in the magnet. The magnetic field lines or magnetic flux cut by the coil. When we push in. Let's say you push in the flux around the magnetic field or flux around the magnet. Cut by the coil. As a result, produce current. Okay, this is also one way. Okay, the conductor cutting the magnetic flux. Okay, conductor cuts magnetic field or magnetic flux, or the coil cut the magnetic flux. So either way. Okay, this is conductor cuts the magnetic flux, or this coil, the coil cut the magnetic flux. So either way produce induced current, and induced current flows in two directions. So today we are going to learn Faraday's law. Okay, and Let's continue with electromagnetic induction. I will teach you this when you come to the class. Next week, this week Saturday, I will continue to teach this electromagnetic induction or motor like this. I will do revision. I do revision. Okay. So today we learn we call it as a preparation. You can see videos. I can prepare and come to the class. This Saturday, Monday and Tuesday there's a class. Okay, this Saturday, Monday and Tuesday there's a class. And as a preparation, you can go to the video. We can come and prepare for the we call it class. Okay, so today we're going to learn Faraday's law. Okay, Faraday's law. Today we're going to learn Faraday's law. Okay, Faraday's law. Faraday's law. Okay, Faraday's law. What is Faraday's law? Faraday's law states that induced magnitude of induced EMF is directly proportional to the rate of a conductor cuts through magnetic flux or change in magnetic flux linkage with coil. Linkage with the coil. Okay, that is called the Faraday's law. These are two important laws in electromagnetic induction. 3.3. Two important laws. They are Faraday's law and Lenz's law. More than Faraday's law, Lenz's law is important, because Lenz's law sometimes we do a lot of questions in the Lenz's law. But Faraday's law will come to the question paper 1, paper 2 and paper 3. There's a practical written practical test on this section. Faraday's law, Lenz's law is not paper 3 but Faraday's law paper 3 questions. Okay, and Faraday's law states that magnitude of induced EMF is directly proportional to the rate of a conductor cuts through magnetic flux or change in magnetic flux linkage with a coil. Either one. Okay, you can read like this. States that the magnitude of induced EMF is directly proportional to the rate of a conductor cuts through magnetic flux. That's one way you say Faraday's law definition. Another way is states that magnitude of induced EMF is directly proportional to the rate of change in magnetic flux linkage with the coil. Because coil also cut the flux. Just now we show you. I show you the coil. Push the coil. Push the magnet through the coil. So I just now show you. Okay. Coil also cut the magnetic flux. So producing induced current. A conductor, north and south pole. Okay. North and south pole. A conductor also cutting magnetic flux. Also producing induced current. So a conductor cuts through magnetic flux, produce induced current. Coil cuts through magnetic flux, also produce induced current. So two ways. So Faraday's law, either way, either this one or this one. Okay, conductor also can cut through magnetic flux and linkage with the coil. Coil also cut the magnetic flux. Like conductor also cuts through magnetic flux. Coil also cut the magnetic flux. So this is what we call it Faraday's law. Okay, so I will explain part by part lah. What is the meaning of magnitude? Magnitude is nilai lah, nilai, the value. And the induced EMF, this is something different. We learn induction, electromagnetic induction produce induced current, but induced EMF. What is EMF? What is EMF? We learned this in chapter 2, EMF, electromotive force. What is EMF? In one word, EMF is voltage. In one word, EMF is voltage. So, you cut the magnetic flux. Okay, you cut the magnetic flux. Flux north and south pole. There's a magnetic flux or magnetic field lines. Okay, you cut through the conductor. You cut through the magnetic flux. You produce induced current. When current is produced, voltage also produced. So induced EMF means induced voltage. So the voltage is not from the battery. Voltage is produced by cutting of flux or cutting of magnetic flux. That is called induced EMF or voltage. Okay, that is called EMF. Okay, we can state the magnitude of induced current also can say lah, but the right definition induced EMF. Induced EMF is not voltage produced by battery. This voltage or EMF produced by cutting of magnetic flux. Induced EMF, induced current. When current is produced, voltage also produced. When current is produced, voltage also produced. Okay, that is called rate of a conductor cuts through magnetic flux. Okay, there are 5 factors. Okay, I will. In other words, this one you can change Faraday's law in a short form. Faraday's law. Magnitude of induced EMF is directly proportional. Magnitude of induced EMF is directly proportional. In other words, Faraday's law, I put it in a short form. Definition you must know. That definition just now I gave you definition. Definition you must write. Sometimes I ask question, what is Faraday's law? So you must give definition. But this is short form. Magnitude of induced EMF is directly proportional to the rate of cutting of magnetic flux. Magnitude of induced EMF directly proportional to the rate of cutting of magnetic flux. The rate of cutting of magnetic flux, there are 5 factors. Okay, the rate of cutting magnetic flux, is 5 factors. The 5 factors. The first factor is a strength of magnetic field. Strength of magnetic field or strength of magnet Okay, strength of magnet. Call it strength of magnet. Okay, second factor, speed of cutting. Third factor, number of turns. Of coil. Fourth factor, angle of cutting. And the fifth factor is length of conductor. Length of conductor. So I'll explain one by one. Okay. Again, I repeat. Magnitude of induced EMF. Nilai. Induce means something produced. It's not what do you call it? Battery. It's not from battery. It's produced. Magnitude of produced EMF, produced voltage is directly proportional to the rate of cutting of magnetic flux. The first factor is the strength of magnet. If you have a strong magnet, let's say you have the weak magnet, okay, let's say the magnet is weak, you cutting the flux. You cut the flux, maybe you produce 20 volt, 30 volt, you produce 20 volt, 30 volt. You produce 20 voltage, 20 volt or 30 volt. But if a strong magnet, the magnet is strong magnet. If a strong magnet, you cut the flux of strong magnet. You cut the flux of strong magnet, you produce 100 volt, 200 volt. You put at the higher voltage. That is called rate of cutting of magnetic flux. Okay, magnetic EMF directly proportional. So you must produce strength of magnet. So the magnet strength. So the magnet is very strong magnet produce a higher voltage. Strong magnet produce higher voltage. Okay. Strong magnet produce higher voltage. Okay. Next one, speed of cutting. Okay, the speed of cutting. Okay, you cut slowly. Slowly cut. Okay, you cut slowly. You produce 20 volt, 30 volt like that. But you cut fast, relatively fast. That is fast. You cut the flux faster. So you produce higher voltage, 200 volt, 100 volt. Higher voltage. Speed of cutting produce higher voltage. Speed increases, what do you call it? Higher voltage produce. Third factor, number of turns of the coil. This one is conductor. Strength of magnet, conductor and coil. Speed of cutting, conductor and coil. Okay, conductor coil. Number of turns of the coil. Number of turns of the coil is coil B. Okay, coil. Okay, for example, let's say you have 5 turns. So this magnet, North pole, South pole, you push in the magnet, the 5 turns of the coil. So you produce voltage. Or current, so 20 volt, 30 volt. Okay, but number of turns increase, so you go more turns. Turn, more turn. 20, 100 turn, 200 turn, you got more turns. Number of turns of coil increases. More turns, you push the magnet, you produce higher voltage. There is 100 volt, 200 volt, or 300 volt. Put higher voltage. You produce higher voltage, number of turns increases. Okay. Now, angle of cutting. Angle of cutting is conductor only. Angle of cutting. So it seems 90 degrees. If you put cutting a slant, you produce low voltage. You cut the flux 90 degrees, angle 90 degrees, you produce higher voltage. Slanting also cut. You can produce induced current, induced voltage. But you cut the flux 90 degrees. You produce higher voltage. So that is called angle of cutting a conductor. So you produce higher voltage. So 90 degrees supposed to be higher voltage. Okay. Next one, length of conductor. Length of conductor means, okay, this is conductor. This is also conductor. This is conductor also. Length of conductor. So you cut, maybe produce 20 volt, 30 volt. But the length of conductor, longer conductor, you cut the flux. Longer conductor. So longer conductor, you produce higher voltage. Maybe produce 100 volt, 200 volt, higher voltage. So conductor increases. Length of conductor increase. So this is the 5 factors. So 5 factors influence rate of cutting of magnetic flux. Kadar pemotongan magnetic flux. Kadar pemotongan flux magnetic. Kadar pemotongan. So it's a kadar pemotongan. It's directly proportional. The magnitude of induced EMF, the value of produced voltage. The value of the produced voltage is directly proportional rate of cutting of magnetic flux. Okay, rate of cutting magnetic flux. So strength of magnet, speed of cutting, number of turns of coil, angle of cutting, and length of conductor. So I'll illustrate to you. Okay. Now, first of all, strength of magnet increases. Okay. This is a magnitude of EMF. Like induced EMF. Induced is not battery voltage. Now again, I repeat to you, the battery voltage, not battery voltage. Induced EMF. So this one, magnitude of induced EMF increases when the strength of magnet increases. When the strength of magnet increases, the magnitude of induced EMF should increase also. Okay. Another factor, speed of cutting increases. Okay, I put a red colored pen. Speed of cutting increases. Okay. Then one, magnitude of induced EMF also increases. Okay. Magnitude of induced EMF. Induced EMF is, again I tell you, it's voltage produced by the cutting of magnetic flux. It's not from the voltage. It's not from the voltage from the battery. It's not voltage from the battery. It's induced EMF. That EMF is produced by cutting of magnetic flux. So the speed of cutting increases, because I'm stressing this point because paper 3, these factors involved. This paper 3, I'll let you know later. Paper 3. Okay, these questions, small questions, paper 3. And paper 2 also, and paper 1 also. This section, Faraday's law, is all the 3 sections. Like Ohm's law. We learned in chapter 2. All 3 sections. Paper 1, paper 2, paper 3. 3 papers also in Ohm's law questions involved. Same like chapter 3, Faraday's law, 3 papers also question involved. Paper 1, paper 2, paper 3. These 3 paper also. Paper 2, section A, section B, section C. Section C. Section A, section B, section C. All the 3 sections can come, these questions. Faraday's law. So this is very, very important. That's why I'm stressing this point again. So magnitude of induced EMF increases when the speed of cutting increases. Okay. And number of turns of the coil increases. Number of turns of coil increases. Number of turns. Now 20 turns or 100 turns. Which one produce higher voltage? 20 turns or 100 turns? 20 turns produce lower voltage, lower EMF. 100 turns, coil got so many turns, coil produce higher voltage, produce higher voltage. So again, the magnitude of a induced EMF increases. So number of turns of the coil increases. Number of turns of coil increases means now magnitude of induced EMF also increases. Okay, and angle of cutting, 90 degrees cutting, 90 degrees cutting increases, 90 degrees, 90 degrees cutting, in magnitude of induced EMF also increases. Magnitude of induced EMF also increases. And the length of conductor increases. Length of conductor increases. Length, conductor. Okay, conductor. For cutting the flux, conductor, longer conductor. You cut the flux longer. Short conductor, short conductor. It is cutting the flux. But longer conductor. This longer conductor. This one longer conductor. Longer conductor or conductor increases. Length of conductor increases. That will increase the magnitude of induced EMF. That will increase the magnitude of induced EMF. Okay? Okay? Magnitude of induced EMF increases, length of conductor increases. So, I will stop. Okay, because Lenz law is an important law. I will take about another half an hour to teach 45 minutes to teach Lenz law, and we have to do the questions. So we meet. I think so. Lenz law is much more difficult to explain, and I would like to explain this one to you directly in the class. Saturday class, and Monday, Tuesday class. When you come to class, I explain to you Lenz law. Maybe I'll explain to you Lenz law, or maybe I will do revision. Depend on your luck and what you ask for. Okay, motor electric, or something you can understand motor electric. Maybe I repeat to you motor electric, or maybe induction. Okay, I will repeat to you again. Okay, so today Faraday's law. Faraday's law is a bit easy, but more questions can be asked in Faraday's law. Paper 1, paper 2, and paper 3. Question can be asked in Faraday's law. But these are 5 factors. Besides this, there's a factor like, for example, the thickness of the wire. What do you call it? Thickness wire is the same factor. Length of conductor under number of turns of coil, strength of magnet, speed of cutting. Okay, thickness of the coil is the same factor. It's a sub-factor. Thickness of the coil, thickness of the wire is a sub-factor. But the factor is the main factor is 5 factors. Okay, 5 factors. Okay, I will finish this end of class today, and I will see you again this Saturday. Okay, this Saturday I will teach you again. Okay, thank you very much.